I'm Larry Rylett, Director of the Mid-America Transportation Center. I'd like to welcome everyone to the first seminar in our seminar series. We hold these approximately every 2 weeks throughout the academic year. For those of you who are not from our center, welcome. Welcome. The center is a U.S. Department of Transportation University Transportation Center for Region 7, Nebraska, Iowa, Kansas, and Missouri. Our theme is safety, and it's related to hazardous goods movements and extreme events, which is why we have this presentation today. We have a number of research thrust areas that look at different aspects of our theme. In this case, we're looking at flood prediction. And it is a multi-university consortium. And today I'm happy to introduce Ricardo Mantilla. He's an assistant professor in the Department of Civil and Environmental Engineering at the University of Iowa. He's been there since 2014, and he's also a research engineer for the Iowa Flood Center. And he'll be talking today about one of the MATC research projects that he's working on. So welcome everyone. Ricardo, we're looking forward to your talk, and I'll let you take over from here. Thank you.
All right. Well, thank you very much for the invitation to present this webinar. It's a great opportunity for us, so I appreciate it a lot. And I want to thank, in particular, Amber and Larissa for helping us with all the logistics of putting this together. And everything, at least the technology part has been taken care of. So anything that goes wrong from now on is my fault. Everybody did their job. So thanks again. I see we have a number of people joining online, and I just want to let them know.
Hello, Ricardo, George.
So if you have issues with my voice,
perfect. So me and Salam can hear you.
Okay, perfect. So now I'm gonna just share my screen so that way I can just get going. Okay, so again, so my name is Ricardo Mantilla, and I'm an assistant professor in the Civil and Environmental Engineering Department, but I'm also a research engineer in the Iowa Flood Center. And even though I started working in the Civil Engineering Department in 2014, I actually been in Iowa since 2008, actually. So I've been part of the development and the creation of the Iowa Flood Center, and is one of the things that keeps a lot of my motivation and a lot of my research going. You know, the number of questions that are being asked here. The Mid-American Transportation Center then gave us the opportunity to ask a question, or at least to make progress towards a question that we have had for quite some time, and is how would we transfer all the knowledge and technologies that we are developing at the Iowa Flood Center to other regions in the country. And we want to make sure, or we want to understand, or want to make sure that our technologies become, or what is needed for our technologies to become transferable, for them to be reliable, and for the information to be actionable. So those three words are actually the umbrella of what we are trying to do with the project that the Mid-America Transportation Center and the DOT is sponsoring for us. So because I want to talk a little bit about, because most of the progress that we have made is on this direction of trying to pass these technologies to others, and to really understand what it takes. I want to start by talking to you, or telling you a little bit about the Iowa Flood Center. Not everybody in the room is familiar with it, and I wanted to use the opportunity for you guys to see what we have done so far, where are we going, and the gaps that we have filled in the state of Iowa when it comes down to flood forecasting and flood prediction and flood preparedness, and then mitigation. So I need to say also that I'm working with, in this project, working with Professor Witek Krajewski, He's a full professor in the Civil and Environmental Engineering department, but he's also the director of the Iowa Flood Center. So he and I work very closely to make sure that all the technologies that we develop and all the science that we develop can translate into tools for the public. So I definitely want to make a big acknowledgement to Vitek and his leadership in the Iowa Flood Center. All right, so I think with that being said, I can tell you a little bit about the Iowa Flood Center. The Iowa Flood Center, the story of this center begins during the historic floods of 2008. And that's why I made that remark that I actually came to Iowa in 2008. I came to Iowa in January of 2008. And at the time I had all these big dreams about floods. I graduated from my PhD and developed a number of theories and models for prediction of floods and understanding of floods. And it was really the flood of 2008 that happened in June that catalyzed a lot of the work that we were doing. And then that flood became kind of a big question for a group of scientists and a group of researchers to try to address here in Iowa. So that story of the center starts there because for us, it was very frustrating that all the damage that was happening in this institute was full of researchers and experts in hydrology. And when all this flood was happening, our hands were pretty much tied. Actually, this is a picture of our institute, the building where our institute is housed. And our basement flooded. It almost made it to the first floor of the construction, but we had to be evacuated for about 3 months, maybe 6. 3 to 6 months, we have to be out because they were doing all this cleaning. And as the flood was happening, it was frustrating that we were supposed to be or at least we consider ourselves the experts. And we realized that a lot of the research that was happening in the institute was benefiting people and places around the world, but the impact of the institute in Iowa wasn't as present and as wide as it could be. So during the floods of 2008, some major cities in Iowa got flooded, in particular Cedar Rapids, which is probably the second largest city in the state of Iowa. The downtown got obliterated. Even today, 10, 11 years after, there are still projects that are part of the recovery from this flood. And this was a multi-billion-dollar catastrophe in the state of Iowa. So I feel like I always have to bring the memory of that flood of 2008 to explain what is the Iowa Flood Center. So in 2009, the scientists and faculty from IIHR, which is an institute that is part of the university, I think our institute is I think in infrastructure is something similar to the Mid-American Transportation Center in terms of infrastructure for research. So the scientists and faculty took what I consider to be a really bold step in approaching the state legislature. We are all, and I say bold because we are all research scientists. We're scientists, so we're used to deal with funding coming from research agencies. So National Science Foundation, NASA, and at the time, nobody I knew really had a lot of experience of dealing directly with the major agencies in the state and the major legislature in the state. So, but they came to the state and they managed to convey this message to the legislatures that the institute and the university had a lot of expertise to offer when it came down to predicting, understanding, and preparing better for floods. So that is the story of the Iowa Flood Center. And we were very lucky that the legislature recognized that we could be partners in moving towards the future after these extraordinary floods. And they established the Iowa Flood Center in the spring of 2009. So the center really started working in the summer of 2009, 1 year after that major flood. But it was really a combined effort of getting legislatures and agencies in the state to realize that we had something to contribute. And the way it got established is that the legislature provided year-to-year funding. So as time was passing by, we were showing to the legislature the progress that we were doing, the kind of technologies that we were developing, and that has led to the to where the Iowa Flood Center sits right now. So now we're talking about 10 years. This year we celebrated the 10 years from the Iowa Flood Center. So now let me tell you a little bit about the technologies and who we are. So the team of the Iowa Flood Center, you can see here right in the middle is our director, Vitek Krajewski, and you see a number of scientists and students that are involved in the work of the Iowa Flood Center. So the Iowa Flood Center has become kind of a big rock that can help us leverage a bunch of other projects, including the project that we're working with MATC. So here what we have is an infrastructure that I'm going to show you that allow us to seek other sources of funding and advanced research at the same time that we are maintaining kind of an operational branch here for the Iowa Flood Center. Okay, so that's a lot of advertising. So now let me tell you specifically about the tools and technologies that the Iowa Flood Center has created. Our mission is, as it's stated in the law or the writing on the foundation of the Iowa Flood Center. So there are a number of things that we want to do. We have a mission of develop hydrological models for estimation of flood frequency and real-time forecasting of floods. So we want to be able to anticipate floods when they are going to happen. And we want to create flood inundation maps. That's another one of our missions. We want to improve flood monitoring, and we want to share our resources and expertise in the state and hopefully now beyond the state. And here, the development of our workforce is another important aspect to keep in mind on the work we do. So again, so I think that at the core of the Iowa Flood Center, one of the things that we're trying to do is to bridge the gap between research and applications. There is this kind of this bad cycle for research that happens, that usually the models that people are using in the literature right now and the most current technologies that people are considered cutting edge, they don't necessarily make their way into agencies, because any new technology is going to come with all the pains of implementation or all the unforeseen issues that a new technology brings. So the Iowa Flood Center kind of sits in between what is a purely academic institution where you're just doing research to push science forward, and the work that agencies do, where they have major responsibilities on responding to natural disasters and to inform the public. So that weight and that liability of the agencies doesn't exist for the Iowa Flood Center. So the Iowa Flood Center can provide kind of that gap, or fill that gap in between any new exciting research that is happening that proves to be better than anything that we have seen before, and turn it into an application that hopefully is a cost-effective solution. So there are 4 areas where we have been pursuing this goal. One of them is the monitoring of rivers. We have done progress on hydraulic modeling, progress on hydrologic modeling towards a real-time automated flood forecasting system. And we have made a lot of progress also in understanding outreach and connecting to the communities and the major agencies in the state. So I'm gonna walk through some of those technologies, again, to bring it, to make everybody aware of the things that can be done in this kind of environment. So the first technology that we're very proud of is the development of an inexpensive sonic sensor that is, in principle, is a simple technology. So this sensor uses an ultrasonic sensor that sends a signal from the deck of the bridge or from the side of the bridge down into the surface, the water surface in the river, and then using sonar can measure the distance between these two places. So in a sense, this instrument allows us to know what is the location of that water surface for wherever the instrument gets installed. So it is, as I said, a technology that, you know, it's a proven technology and it's a known technology, but the Iowa Flood Center then took the step of making an implementation of this technology and developing protocols for installing the instrument. So on the left, you see the picture of one of our engineers installing one of the instruments in the bridge. And I can give you a little bit of a closer look here at what the instrument looks like. The instrument has a rechargeable battery that is attached to a solar panel. In general, the panel, we install the sensor downstream, in the downstream part of the bridge, so that the instrument never gets impacted directly by the flood or flood waters or the flood debris, but it's kind of in the back of the bridge and is looking at that downstream part of the bridge. So it has a battery, solar panel that charges that battery. There is a GPS unit in there, mostly to keep the clock. So GPS clocks are very precise, so that allows us to keep a good measure of time. There is a cell phone antenna and a cell phone board connected to the system. So that way, that allows us to communicate information in essentially text messages. So we're sending text messages from the instrument into the computers in our institute to collect the information that they gather every 15 minutes. And finally, there is a little board here that is actually also an in-house design that essentially collects the information from the sensor, packages all the information in a nice text file, and then that information then is relied every 15 minutes. That information is sent through the cell phone antenna. So the whole technology really is a combination of technologies that exist, but is put together in a quite a reliable instrument. Those instruments get tested in-house. A lot of students participate in the construction, and I think that now we have a pretty stable design that has proven its value over the last few years. So we can produce, large numbers of instruments. We have produced groups of 50 instruments and installed for agencies in Iowa. And we test them to make sure that they are waterproof. So we actually submerge them in water before we deploy them in the field. So that's on the side of monitoring. So we have been able to go from about 120 flood monitoring gauges in 2008. So all these flood gauges that you see, all those stream flow gauges that you see in the map are the locations in Iowa where the USGS had gauges running, and if you know a little bit about the history of flood gauges in the United States, you know that we are on a phase of declining number of stream flow gauges throughout the country. and Iowa is not exception. I think Iowa went from having 300 or so sites in the 70s and 80s to now having those 120 sites more or less stable in the state. So now what we can do with this more inexpensive instrument, because one of these things cost about $3,000 a piece to build and install, is what we can do is that we can grow the number of sites that can be monitored. And there are a number of places that where flooding is a recurrent issue. So having an instrument there it provides value by itself. But it's essentially just grow our view of how floods occur in Iowa, you know, and what locations get impacted, and kind of the spatial correlation of floods in the state. So that's on the side of monitoring. And I like to say that we're always proud of our instruments. They have been in floods, so they have been tested in action. They have been able to handle major floods and also the winter. So not everybody can handle the winter in Iowa. You know, I'm from Colombia, so to me, that's always a test. Anything that can survive a winter in the Midwest. And as I said, those instruments get installed in the sites of bridges. And one of the things that we were happy to see is that if you look at this hydrograph, this is a measure of stage for different moments of time. And here, when this hydrograph was going up and the instrument got flooded, so then it stopped sending information or sent erroneous information. But then when the water started receding, then the instrument came back to life and continued working. So that's one of the technologies that we have developed that we think is very reliable, and one that we think that can be transferred. It's one of the technologies that can be transferred. The other technology has to do with flood mapping. This is again an existing technology, but one that when the Iowa Flood Center came to the state or came to town, we realized that a lot of the inundation maps that get developed for different places in the state, they are produced by different consulting companies, sometimes by agencies, sometimes by the counties or cities themselves. So there is a lot of heterogeneity on how these maps get produced. And with that heterogeneity, that also translates on the accuracy or perceived accuracy of these maps. And if you know something about hydraulic modeling, there are a lot of details and a lot of assumptions that go into the constructions of these maps. So the Iowa Flood Center became part of the statewide floodplain mapping program. So the Flood Center provided the expertise and the direction, and the state funded the Iowa Flood Center to create maps for the entire state, flood inundation maps for the entire state. So we did this process in 4 steps. So we were able to determine the hydrography of the state using a LiDAR map that was existing in the state. This is a 1 meter LiDAR digital elevation model. After that, we calculated the hydrology. So we determined for each branch in the river network, we use regionalization equations to determine things like the 100-year flood, the 500-year flood, or I should say the 1% flood or the 0.2% flood for different recurrence probability of exceedance. And those numbers allow us to construct hydraulic models that would give us information about the inundation zones that would be influenced by different values of floods. So we created 2 types of maps. We created a set of very detailed inundation maps for the major cities in the state of Iowa. And those have been developed over time. So this is a little bit of a time series of the maps that have been created. So we started with the bigger cities, Des Moines, Cedar Rapids, Charles City, but then as time progressed, we have been going through the state to build the newer maps for each one of these locations. So these particular maps, they use a two-dimensional hydraulic modeling. And this modeling is supported on as a technology that already exists in IIHR to scan the bottom of rivers in this major location, so we can get a very good picture of the bathymetry of the river, and that allows us to create what we consider to be very precise inundation maps for the major cities in Iowa. So that's another technology that exists, and a technology that is useful and actionable there. So hopefully I will have a chance to show you more about these maps. But in addition to the one-dimensional, to the precise two-dimensional maps, the state sponsored the application of a more simplified technology to create inundation maps for the entire state. So now we have maps that will tell us or give us a guidance on the inundation that can happen for different recurrence periods or different probabilities of exceedance. These are maps produced with 1D hydraulic models. So for anybody in the world of engineering, nothing too far away from something like HeadCRAS or one of these one-dimensional tools. So if you zoom in Iowa, then you will see that every stream that drains more than a square mile will have a map that provides an estimation of the inundation zone for the state. Okay, so that's technology number 2. So we have monitoring and we have hydraulic modeling so far. And next, another technology that I think that is one of the technologies that have most development and that we think that can really benefit the state and other places as well, and is the creation of a statewide rainfall runoff model. So our model is a hydrological model. I'm not going to go too much into the details, but I do want to say that the kind of at the core of our hydrological model is the decomposition of the landscape into what we call links and hill slope areas. So here, when you look at the landscape, you have a river network that, in this case, a lot of the rivers can be, or a lot of the river pathways can be dry when it's not raining, but when rain is happening, these are very efficient pathways for water, and then the area that drains into each one of these links of the river network, they become the control volumes for our numerical model. So long story short, is a high resolution decomposition of the terrain that is based on the local geomorphology. These are a couple of pictures. So this is a picture of the river network. I just wanted to show kind of the level of detail in the model. So this is the river network near Greeley. This is in northeast Iowa. And when you zoom in, these blue lines are the network that the model sees. So this is how the model will try to move water through this blue river network, and then will move water from the hill slope area that corresponds to that channel. So water will land in the landscape in one of these units, and then will either infiltrate or find its way into the channel, and then water gets routed from one channel to the next until it reaches an outlet of interest. So in general, all the parameters describing each one of these units are unique, and they describe the conductivity, infiltration, slope, roughness for each one of those terrain units. So at the end of the day, that ends up with what we call is a system of ordinary differential equations, and we develop technologies to solve those equations very efficiently. So to the model, this is what Iowa looks like. So it's the state of Iowa. As you can see, there is a little bit of the domain that is outside of Iowa. So that is areas that when it rains, the water goes through Iowa. So parts of Minnesota are part of what I would say the water boundary of the state. And the model is essentially just for each one of those individual hill slopes or those units of terrain, is calculating how much water gets there, how much it infiltrates, and how it moves through the state. And we have a network of radars that allow us to see precipitation. And this is the national network of radars. So that's that is homogeneous throughout the Midwest, in particular on the 4 states that we're concerned with in the Mid-American Transportation Center. And as I said, a lot of the work that we did, I'm gonna say kind of the first 5 or 6 years of the Iowa Flood Center, they were spent on research and development. So creating the tools that could provide information for Iowans, including the model. And now there has been a transition in the center to be a more operational type of operation, if I can be redundant there. So it's a more operational field where we have professional engineers and professional systems people that keep all these computers running and keep all our technology in place. Now, what is the value of this particular type of hydrologic modeling? And it's that it can give us predictions of flooding anywhere in the river network, right? So that includes all the riverine communities that exist in Iowa, right? So if you compare this map, these are all the riverine communities with more than 200 inhabitants that are in the state of Iowa. And if you compare that to the first 120 stations for monitoring stream flow, you know that there is a big gap between the information that is provided by the USGS and the need for information that is throughout the state. So that is the technology number 3 that we have invested a lot of time and effort. And you know, along the way, I can tell you, and you can probably imagine that there have been a number of mistakes that we made along the way, a lot of theories that proved wrong, and a lot of theories that actually proved right, and are now at the core of this technology. With that being said, we have done some significant evaluations of performance of the model, and this is just kind of a picture of overall performance of the model in the state of Iowa. And this goes without saying that when you try to have a homogeneous hydrologic model for the entire state, then you are going to start finding places where the model performs better than in others. So this is a realization that we have had for quite some time, and we continue to work to maximize the performance of the model. So right now, the long story short is that our modeling is very good in Eastern Iowa and decreases the performance decreases in Western Iowa. And we'll get in a minute or later, we'll talk a little bit about the reasons why and how the solution of this problem is part of the technologies, or at least the frameworks that we're developing to transfer this technology to other regions. And then, you know, to kind of round up, the work that's been doing this is being done in the Iowa Flood Center. The fourth area where we emphasize is outreach. So how to communicate all this information that we now have, right? We have inundation maps, we have predictions made by this model on floods. We have different types of forecasts that are being done, and we have all the information of the sensors that is being collected throughout the state, and we want the community and any stakeholder in the world of floods in the state of Iowa to have access to that information. So to that end, we created the Iowa Flood Information System. Another one of the researchers of the center, Ibrahim Demir, he's an expert on information systems to communicate environmental information, and he has done a tremendous job at creating this site. And if time allows, I am going to go live in a few minutes to show you some of this technology, but for now, I just want to kind of give you an overview of what it is. So this is a web-based technology. So anybody with a browser can go to the Iowa Flood Center website and activate this tool. And in there, you're going to find, when you deploy the tool, you will find a map that is ready to be filled with information. So you can ask for things like, show me the location of the instruments in Iowa, sensors of stream flow. And then if you click on them, then you can get the information that these sensors are observing, together with a prediction of what is going to happen to the water after that particular moment in time into the future. So now this interface here combines, or at least transmit, the information of multiple technologies. So we have our sensors that are making measurements and our hydrological model that is telling us what is going to happen in the next 10 days. And that's an update that occurs every 15 minutes. Our model makes a new calculation about what's going to be happening. So as rain happens, the model updates its prediction of what locations in the state can be subject to flooding. There are a number of interfaces that allow to visualize the forecast. And we're working on tools that allow us to communicate to the public using inundation maps instead of giving them a hydrograph of what's going to happen, right? Because when you go to the public and you tell them, hey, tomorrow there's a flood coming and the flood stage is going to be 31 feet, the majority of people have no idea what those 31 feet are, where are they measured from, or what is the, what does it mean for them 31 feet, right? But when you translate that information, that inundation, that flood stage, or that stage in the river to a map, then that informs the public better about, what time do they have to prepare, what areas of the community are more critical to be prepared. And here in this example, I have here there is the Cedar Rapids Public Library. That's an example of a property that the city would like to protect in a prediction like this. We have been beginning to compile information from FEMA about properties that get affected by this inundation. This is now part of the technology. We not only have the maps of inundation, but we have combined that with information of structures in the ground. So that is a little bit of the story of what has been happening over these last 10 years. So we have developed all these technologies that allow us to communicate the new information that we have and the tools that we have that we're developing and evaluating to the public. We continue to develop more novel technologies. We have a group here that is dedicated to find new ways to communicate information. What you see in the picture is a virtual reality, or actually an augmented reality scenario where people can put one of these 3D glasses and they can look at the environment around them just to see what things would look like in the case of a flood. So this technology is still not out there for the public, but it's part of the technologies that we continue to develop. But more importantly, in these 10 years, what has happened is that we have been able to connect with a lot of the agencies that deal with water in the state. And the center has served as the platform to not only communicate with agencies, but it's been kind of a center that supported some experiments that NASA was doing to test their satellite products. So again, this is kind of still an academic institute that is providing kind of a backbone for a lot of other activities. And one of the things that I'm actually very proud of is our relationship with the National Weather Service. They see the Iowa Flood Center in Iowa as a complementary group for the work that they do. They are still the agency with all the liability and responsibility on flood prediction, but now that they have seen that our developments are fairly consistent, they have been in communication with us, and we give them our forecast so that they can contrast our forecast with their forecast, and that gives them at least another eye on those predictions. So in 2016, we were in very close communication. There was a major flood in Cedar Rapids, and we were in close communication with the National Weather Service. We were able to provide them with the numbers that we were expecting, the inundation zones that we were expecting. And long and behold, our prediction was not bad. We predicted the crest of the flood really well, but our models predicted the arrival of the flood wave just a day before than when it happened. So we know there is room for improvement, but now the information is becoming reliable and consistent enough that we can confidently communicate with agencies and make our number part of the actionable information for agencies. And we think we can do this not only with the National Weather Service, but with agencies like the Department of Transportation that takes care of now monitoring hundreds and hundreds of if not thousands of river crossings, where the possibility of the interaction of a flood with a vehicle can be relatively frequent. Okay, so now to kind of close that idea. So with that, I gave you, a lot of the things that are happening in the Iowa Flood Center, and our desire to understand how to transfer all these technologies to another place, right? Because it would be a waste of time if just all of a sudden Missouri decides to create a Missouri Flood Center and they start from scratch to build all of those technologies and then suffer the growing pains that we did. So our MATC project has been has progress or is making progress towards developing tools, frameworks, and methodologies for technology transfer. And we want all our tools to be, as I said at the beginning, transferable, reliable, and actionable. So we want those three things in place in case that the outcome of this project is that the other DOTs or the other states realize that it would be convenient for them to have all this technology in their hands, and that the transfer of that technology wouldn't be a major or wouldn't be the biggest headache to deal with. So as you see here, we have already begun collecting and determining whether the information that is needed for all these tools to work exists in the States. So most of the work we have been doing has been on transferring the predictions of the hydrologic model to those regions. So here we have, this picture shows the river network of Nebraska, Kansas, and Missouri. And we have been testing whether our computers would be able to handle calculations for those places. And then in general, kind of our project goals, or the one thing that we're kind of trying to make forward, is we want to create a flexible methodology for parameterization outside of the Iowa domain. We want to create interfaces for the exhaustive comparison of model configurations. And we want to create tools to provide local forecasts as inundation maps instead of hydrographs. And finally, we want to incorporate use data simulation techniques to make the predictions of hydrological models more reliable. And towards that end, we have been making progress, and thanks to this project from MATC, we have been able to test a number of technologies and techniques that now give us more confidence that we can improve the performance of the model in regions that we haven't been before. And that's a lot of the action that's been happening in this first year. So we developed tools to make our model and the information that we transmit reliable. So we created a number of graphical user interfaces. Those are not publicly available, but they allow us to examine the model in great detail and determine whether the predictions that are being done are accurate enough to become actionable. And then finally, we're making, as part of making this information actionable, we want to make sure that when we provide a map like this one that is showing places with inundations, that a user can zoom in, and then what they are going to see is the inundation zone around that area of interest, or whether it's a city or some farm in the middle of Iowa, that they all have this kind of uniform information. And then finally, as I said, the incorporation of data simulation. That's again, no hydrologic model is perfect. So we know that we make incorrect predictions every now and then. But because we now have a bigger wealth of data, we can use that data to make corrections in the model so that the forecast towards the future become a little more reliable. So then, we go from an original forecast here. This is a gray line that we can adjust using the past observations, and then our model will make a prediction that is more likely to be correct.
Ricardo, this is Larry. I think we have a bit of time. If you want to just show us the live demo, I think that would be very useful for a lot of the people that are here.
Okay. So you're still seeing my screen, right? Okay, here we go. So let me start here. So this is the main website for the Iowa Flood Center, and there you can find more information, or the information I gave you, a little bit of some of the things in more detail. But this tool here on the right, IFIS, is our platform for communication of flood-related information. So when you click on it, you can go to a series of interfaces, but we're going to start from scratch. So we're launching IFIS. And the first thing you're going to see is a map of the state of Iowa. And the tools on the right essentially will allow us to populate with information this map. So we can start with something like, okay, show me where all the stream gauges in the state are located. So here, the green ones are rain gauges, stream flow gauges that are maintained and run by the USGS. So if you click on any one of those, then you can get the current state of the stage in the state. So that's what's happening there. But you can also see our instruments. This is the information for our one of our sonic sensors that is measuring the depth. And you can look at the history of, well, right now the rivers are fairly calm. There hasn't been major storms in this last couple of weeks. So not much action is actually going on. But you can also look at things like rainfall, like you can ask, any user can come and ask what's been the rainfall in the last 2 weeks. So here, if I zoom out a little bit, then I can see that information, right? And for any station every station is attached to a forecast of the model. So if you are, say, in Cedar Rapids or I don't know, or Ames, I'm gonna do Ames just because I see it there right away. So you the platform will zoom in, show you what is happening in, currently what is happening in Ames, but you can also play with the scenarios. You can say, hey, what happens if the discharge coming down this river is, I don't know, what did I say here? 15,000 cubic feet per second, and the stage is 24. And because this is a river with 2 branches, you can play with a little bit of a scenarios of what would be the inundation for a particular type of a scenario. So these are the tools that we are giving to the public so that they can be informed and prepare themselves for that. So, you know, if you're gonna buy a house and one of these maps is available, then you can go and see if your house is in the, say, in the 500 year floodplain. So we have those annual chances here. So we look, say, at the 500-year flood, right? And then you can zoom in, and then it seems like Ames has done a good job at buying off the floodplain. Okay, but not in the university. So few buildings here would be inundated, including their Coliseum. So anyways, so that's information that can be, that we give to the public, and we try to give information that we are very sure that is correct and that can be used in action. So the other kind of live demo I wanted to give was on these tools that we have been developing to make evaluation of our model. So this is part of the technologies that we think that will make our model and our framework for predicting floods transferable to other places. So what you're seeing here is a map of the river network in Iowa. And each one of those dots are locations where there are stream flow gauges that have historical records. And when I click on any of them, it shows me the catchment associated to that place. Let me see. Yep. Okay, so then for any one of those catchments, I can inquire how good the model has been historically on that location, right? And this is in particular 2008. So here, obviously, I am going to show you one of the moments where the model was the best. There are moments when the model is not the best. And here, so this is a prediction. The blue line is the prediction that the model did throughout that particular year. But because we are constantly thinking of ways to modify the model and maybe to make it better in different regions, we can compare the performance of different model configurations. So this is one of the frameworks, because when we move out of Iowa and we go into Nebraska, the dominant hydrological conditions might be slightly different, or will be slightly different. Actually, infiltration is a lot bigger in Nebraska, and there are a number of physical processes that are not dominant in Iowa. So when we move our technology there, we want to make sure that we have in hand all the tools that will allow us to redevelop our model if necessary, and to evaluate the performance of that model in these new locations. And we want that to be something fast and something that it won't take us those 5 years to just get there, right? So it will be something a lot faster. And then we have technologies that actually allow us to see the ins and outs of everything that is happening inside the model. So this, for example, is a reconstruction of what happened in 2008 in the state of Iowa. So let me see if I can make this faster, just end there. So here you see all the precipitation that was falling on the state and how that water was moving through the rivers of Iowa. And then when that second round of storms came, created that big inundation that became the major flood that Cedar Rapids observed. So you can see quickly the river network here is getting into the purple colors of major flood throughout the state. So we can see the output of the model, but we can also see what's happening in there, what was the state of the soil moisture in different moments in time. So then as precipitation was falling in, soils were getting more saturated, and soils that are more saturated are more likely to produce surface runoff that then goes to the rivers and transforms into that epic flood that we saw.